So I'm happy to welcome the first speaker, Professor 21.Shiju Sathyadevan. He's the Assistant Professor, IoT, Big Data and Visualization Research at Amrita Cybersecurity Center, Amrita University. And he's going to be talking about a very specific case study that Amrita University has developed and deployed, IoT in a mulberry farm. Professor 21.Shiju, please.
Professor 21.Shiju Sathyadevan. I'm actually from Amrita University, specifically working in the area of Internet of Things, Big Data and Visualization. Just to give a brief rundown, before that, I got two of my colleagues also here. Mr. Jinesh, who is actually finishing his PhD in formal methods and who's been a core architect in the entire IoT framework that we have built. And also Mr. Deepu, who is actually a very hands-on person who's actually played a critical role in getting all this up and running. Hello. Okay. Amrita University as such has got 5 campuses, and I represent from the Amritapuri campus, which is in Kollam in Kerala. Organization is actually from the MUD, Mata Amritanta by MUD. Amma is actually the chancellor of this university as well. And the core thing is that every project, every research that we do at Amrita is actually having a humanitarian incline. Everything that has to be done, every research that is being done so far, if you look at Amrita history, if you go through Amrita website, every research that is being done is being implemented. We have 148 villages that has been adopted across the country, and we have implemented every solution that we have done across 148 villages. A huge stream of work that we have taken up is called Live in Labs, which has attracted students and researchers from all over the world to come across and then spend their time in the villages, identify problems and trying to find solutions for it, and then they go back and do it. All this is actually based on, clearly on the guidance of Amma. So the Karshaga Amrita Dhara is actually a contribution that's been done for farmers of India, seeing the real problems that they face. One of our campuses, our main campuses run out of Coimbatore, and there are a lot of farmers in and around that region, and they face a major problem, and that is, they have a big shortage of power, and also the big shortage of water. So how do they actually able to manage it? And that's how Karshaga Amrita Dhara just came up. It's just not an offshoot, but it actually came out as part of the project that we've been doing, which is on IoT, Big Data and Visualization. I'll give you a quick rundown of what we have done so far, and then pretty much everything is available. It's all running. We have showcased to a lot of corporates and a lot of other solution providers, and they're all very keen in seeing the solution. Tomorrow also I'm actually giving a presentation in which I'm actually giving a walkthrough through all the solutions that we've developed so far. Just a quick rundown. These are the various aspects that we have done. We started this work in 2013. 2012, we were actually being called in by DAITI, Joint Secretary by Ajay Kumar, to have a discussion with few other institutions like IITs, NASCOM, to start up an initiative on IoT in India. And then based on which Dr. Ajay Kumar actually committed that he is actually ready to give us, at least ready to approve 4 projects related to IoT. We submitted a proposal, and based on which in 2013 March, we got a funding of 3.24 crores, which we actually used to build the entire framework. So what our approach has been to build not only just an IoT middleware, but also a processing framework and also a visualization engine with a lot of IoT enablers, which I will talk in detail for my talk for tomorrow. These are the components that we actually use, which is AIoT, which is Amrita Internet of Things middleware, which actually sits at the hub, which you can say can be something which is hosted as on a cloud, which actually controls, manages everything, as you know what a middleware does. But we have a slightly different approach, which what we think is, IoT is not something which can be centralized onto a middleware. It has to be divided into multiple subsets, and that has to be run out of a gateway that has to be intelligent enough. Because if you look at the gateways that are going to be used, it's actually specific to an application. For example, if you have devices that is actually using Wi-Fi or Bluetooth, or if you have 6LoWPAN devices that is running out of it, you have gateways which specifically supports that. But what happens if you want to implant this into a smart city where you think about people using umpteen number of protocol-based devices across, and then you probably will not be able to thinking of putting gateways which actually support each one of them separately. That's where we came up with a new concept called protocol characterization technique. This is a patented work that we have done. The technology is that the underlying communication layer is intelligent enough. That means a protocol which is similar to the existing protocol comes up, it is able to query that protocol, do a profiling, and then able to rebuild its intelligence so that it should be able to communicate with that device automatically without you needing to do anything with that device. So normally if you take a device, if you want to make it IoT enabled, probably what you try to do is you actually write some piece of code which actually converts it into a REST format or something which is more understandable by the cloud platform or a gateway. That's what you normally do. That means you expect the user to be a little bit more savvy. So as a layman user, I probably will not be able to use this. That's where we thought, this has to change. If I want to make a device IoT enabled, I should be able to just put it there, and the rest should be done by the gateways and the middleware that should be there. So that's where the whole concept got built up. That's where our gateway has called something called protocol characterization layer. Again, one of the major problems that most of the people will raise is going to be the latency that is involved. How are we going to circumvent the issue of latency that is going to be induced? Another thing is connectivity. Do you think that we get 100% connectivity at all times? What happens if the connectivity goes down when there's a critical incident that is happening? Will it go unreported? That's where we think that IoT cannot be driven out of a cloud. That has to be done locally. That's where our IoT gateways come with protocol characterization layer and with the capability to run IoT applets. We call it as IoT A's or IoT applets, which can be run directly on top of it. That means decision making takes place locally, and whenever you need data to be pushed onto the cloud, as per the availability of the connectivity, the data get pushed onto the cloud. We have developed a programming language called EventJ, which is specifically for concurrent programming. Normally what happens is if you use Java-like kind of platform, you probably need to take care of threading by yourself. But here, concurrent programming, it uses PyCalculus methodology to develop. That makes user life much easier. So it automatically looks at the various cores available, the available resources, and then it scales accordingly. So that takes out a lot of the programming overheads that you probably would have using traditional programming languages. We have topic-based authentication. MQTT. We also support ZMQ and Kafka. We have something called Devi, which is called Device Virtualizer. Now, the major question that is going to come up is how are you going to stress test your applications? You probably would like to, you can't have millions of devices out there for you to just stress test your application. So that's where Devi comes into picture. Here, you probably would like to, you can just go say, I would like to have 4 networks, and I should have about 50 Zixlopan devices, 20 Zigbee devices, 30 Wi-Fi devices, and push me the data. It actually pushes you the data, and that can hit your application. You can actually see how well your application scales. So this is device virtualizer. Another major problem that we think is going to be for IoT is going to be the device cost, the cost of the devices. When we started this project, the first thing what we decided to do is we went out to the market trying to buy an RFID reader. That's one thing that we did, because RFID was considered as one of the most important things which is actually going to be part of the IoT enabling. So we went ahead. It was costing about 1.2 lakhs to get one in a decent impinj, which is a foreign, I don't know which country it's been made, in an impinj RFID reader. We thought, like, if this is the kind of exorbitant rate that you have to pay for RFID readers, how is it going to be implemented worldwide? I mean, on a massive scale. Second thing was we tried to procure modes. The modes that we tried to buy was actually going to cost us anywhere between 7,000 rupees to 18,000 rupees. That's the kind of cost that we had to pay for the modes. So we thought, like, that's not the way to go forward. There should be a way to cut the cost down so that IoT can be implemented pretty much at a very low cost. That's where we came up with an RFID reader. We call it an Astra, which is a very low cost device. Then we came out with A-mode, which is actually a basic mode wherein which have USB interfaces. You can easily convert your sensors into a USB pluggable format, which you can actually plug into this A-mode. And then we have an RF transceiver called low-Z. It's, a lot of people actually says it sounds like lousy, but it's not lousy, but it's lousy. Why? Because it actually got the capability to load either 6-LoWPAN stack onto it, or you can actually load Zigbee stack onto it. And then readily it can communicate. It's showing high performance. It's actually showing it with a ducky antenna. We can get up to 800 meters under high humid conditions, like in a beach, a kilometer in normal conditions, of course in line of sight. And then the cost for that is actually coming down to about 350 rupees. But in bulk production, I think we can even drive the cost down. So A modes are also pretty cheap. That also comes in the range of about 250 to 300 rupees. We have a Homer kit, which we call it as a home automation kit, which is very popular nowadays. Everywhere you turn around, you can see one of these, which fits inside the smart. We also have a fully integrated system with a whole set of sensors, which can actually go and that can be planted along with this Homer device. The difference is that every individual devices can be monitored. It's not only control and then manage it, you can also measure all the power factors that is actually associated with each device. So that's also being done. And then we have a full set of LoRa-based modes for long-distance communications. Of course, Karshaka Amrita, which is the automated irrigation control system. Another important thing that we integrated to the middleware is query user interface. That means you can, as a layman, you should be able to query your sensors at any point of time just by asking mere questions. What is the status of that particular sensor? Or you should be able to actually ask, give me the status of this sensor for the last 15 minutes or so, and then it should be able to give you that sensor on a layman's language. That's QUI, a rich pool of APIs for you to do application development pretty quickly, and then applications, the applications that you actually communicate with the middleware, that also need to be integrated with it. Amrita Big Data Framework. I'm actually going to give you a demo of that also. It has generated a lot of interest. It actually is a framework, a GUI-based framework. Those of people who actually used ETL will be very familiar to that. The difference is that this has got analytics capability plus data mining capability, and it can run on top of Spark and also on Hadoop. It can take streaming data. It supports Kafka, it can support MQTT, it supports ZMQ. It can do PCAP analysis. It can take data from HDFS. It can take from FTP flat file, and it pretty much makes the life of you much easier by mere drag and drop. You can build an entire pipeline, and then it processes it, pushes the data onto the visualization platform, and you can visualize it interactively. That's it. Once you push the data, it's not that static data. You can interactively work with it. You can drag and drop other functionality like aggregations on top of it. You can create window functions saying that if you want to process the data for the 5 minutes window, you would like to see how the 5 minutes window progresses. You can apply that statistical analysis that can be performed onto it. A lot of work on security as well. Now, get into CAD, Karshaka Amrita Dhara. The major problem which the farmers in Tamil Nadu that we visited has faced, and also we actually talked to a lot of farmers in Tamil Nadu Agricultural University. The major problem they faced was that scarcity of water and also electricity. Electricity is something which has been provided for free for farmers in Tamil Nadu, because of which most of the times during daytime there is no power. So what happens is they have to keep awake during night, and then they have to do the irrigation during night. The problem is they use something like a 7 HP or 8 HP motor, and that pumps the water, and then that is not good enough to irrigate a 4-acre or 5-acre land. So what they do is they go to, at night, they go to each valve, turn it on, irrigate that part of the land. When it's done, they close it off, done. So the cycle goes on like this. So sometimes they fall asleep. So what happens is the motor runs the entire night, and they lose the whole water. They waste a lot of water and electricity. This is what's happening. Now the system, what the CAD system does is, it's a fully automated system. It runs out of a gateway, which I told before. Our application, the KAD application, runs on top of the communication layer. So what it does is, the gateway wakes up all the sensors. They all go to sleep when they're not needed, so that it saves power. We use soil moisture sensors and soil temperature sensors. Some of the farmers, when they do specific crops like vegetables, they would like to know the temperature of the soil also, because it looks like in some of the cases, they might have enough water, but the temperature might not be sufficient enough or good enough for that crop to grow. So they would like to maintain that temperature also. So our soil moisture sensor can do not only the water content or moisture content, but also measures the temperature within the soil. It's all running out of Zigbee. We have used solenoids, which we didn't build. We bought it from outside, but it was so expensive. It was costing us about 4,800 rupees to buy a solenoid, which fits in the 2-inch pipe. So now what we decided, there's no point of us actually buying something, making all the changes to the existing pipeline. So what we decided is we developed an arm which will actually sit on top of the existing gate valves. Gate valves, you probably might have seen, is like a pretty tight valve which controls the flow of water. So this goes and sits on top of it. It's again controlled by Zigbee. And then that controls the way that the water flows and irrigates at different parts of the farm. And then we have motor control unit, which actually does all the preliminary checks, whether there's enough power, enough voltage to kickstart the cycle so that it can kickstart the motor. And then there's a flow meter which actually ensures that the water is actually getting pumped, and if the water is not getting pumped, it cuts off the motor. The whole system has been developed. So what happened? The process goes like this. If it's a schedule-based irrigation control system, then what happens? It wakes up at a certain point of time, for example, 4 o'clock. Then it actually wakes up all the sensors. It asks for values from all the different sensors. It looks at the soil moisture content, and then it sees that there is water requirement. The threshold has been set to 75%. 3 minutes more? Okay. So, and then based on which it actually irrigates land. And then once there is enough of water that's been supplied to one part of the farm, it cuts off that, and then it turns on the next solenoid, and then the irrigation continues till the end. If power goes off in between, it actually resumes from where it actually stopped, and it continues. So here I got some pictures. This is how the land has been. This is a 4-acre mulberry land. Later on, he completed a full cycle of 9 months mulberry cultivation, completely using our irrigation control system, and then he went on to do a 5 months vegetable cultivation. That also is being done completely, fully using this. Seeing this, a lot of farmers has actually come requesting this solution to be implemented. The cost is very low. We kept the cost as low as possible. Soil moisture sensors is costing about 600 rupees. And then, the controller gateway, controller valves is costing close to about 800 to 1,000 rupees. I think the cost can be cut down considerably if you go for bulk production again. So this is the gateway that we actually built. This is the gateway that runs out at the farmer's location. This is actually the soil moisture sensor and also the soil temperature sensor that we use. This is the motor control unit. And then this is the gate arm, which actually sits on top of the gateway. The gate valves, which actually controls it automatically to turn it on or off. And then we have the gateway backup unit, because gateway is something which need to be up and running all the time, so that we have a backup unit also for that. And then we are also now trying to, we already built that, we are actually testing it out. One of the major problems is like all of these need substantial amount of power, so it cannot run on, and we tried to put AC directly onto this, but the farmers were not happy. Now we have developed a centralized solar system which will actually deliver power to all of these different devices. I'll just show you a quick video. Can you run that video, please? Yeah, that's right. Ends with the video.
brilliant presentation. I would just have one question. When are you starting a company? And Shyam Menon, is he here? Infuse Ventures? No? I'd ask him, when are you funding him? Great. Thanks a lot. Thanks a lot. Excellent presentation. This is exactly what India needs. And, you know, I'm impressed by the level of sophistication and so forth they have put in. Sir, just a quick piece. I'd like to give you a memento, please.